In this episode, we're going to build a beginner-friendly understanding of what security information and event management (SIEM) systems are trying to do and what it feels like to analyze events inside them. People often hear SIEM and assume it is a magic machine that detects all attacks automatically, but the reality is both more limited and more interesting. A SIEM is a way of collecting security-relevant data from many places, organizing it so it can be searched and analyzed, and producing signals that help humans detect and respond to threats. Its value comes from combining many small pieces of information that would be hard to interpret in isolation. At the same time, SIEM work is not just about technology. It is about judgment, prioritization, and dealing with uncertainty under time pressure. Understanding the basics means understanding concepts like normalization and correlation, but it also means understanding why alerts can be noisy and why analysts spend so much time chasing what turns out to be benign. By the end of this, you should be able to explain the purpose of SIEM, what normalizing and correlating data means, and how alerting works in a real analyst workflow. A good starting point is understanding why SIEM exists at all, because once you understand the problem it solves, the concepts make more sense. Modern environments produce huge amounts of activity, and that activity is spread across endpoints, servers, applications, networks, identity systems, and cloud services. Each source might have its own logging format and its own vocabulary, which makes it hard to ask a simple question like which user accessed this sensitive system and from where. If you try to investigate directly in each source, you waste time, and you can miss connections that only appear when you see events side by side. SIEM brings these logs together, stores them, and makes them searchable in one place. It also enables detection logic that looks across sources, such as linking a suspicious login to unusual network traffic and then to a sensitive file access event. That cross-source linking is where SIEM can provide real security value, because attackers often spread their actions across multiple systems. The SIEM helps you see the story rather than only isolated sentences. Normalization is one of the first core concepts, and it is easiest to understand as translation into a common language. Different systems describe similar events in different ways, such as one log source calling an identity field user, another calling it account, and another calling it principal. If you want to search across sources, you need a consistent way to refer to the same concept. Normalization takes raw events and maps important fields into a standard structure so that searches, dashboards, and detections can work consistently. This is not just about renaming fields. It is about making sure that time, identity, device, source and destination, action type, and outcome can be interpreted reliably. For beginners, the key idea is that normalization reduces friction in analysis because it allows an analyst to ask a question once and get relevant results from many sources. Without normalization, every investigation becomes a series of special cases, and detections become fragile because they depend on unique formats. Normalization is also where data quality matters, because if a field is mapped incorrectly, an analyst can be misled and a detection can fail silently. When you hear that SIEM work includes data onboarding and parsing, this is the heart of what those tasks are trying to accomplish. Correlation is the second core concept, and it is about connecting events that may be related so you can see behavior patterns. A single event, like one failed login, usually does not mean much, but a pattern of failures followed by a success might mean someone is guessing credentials. A single network connection to an unusual destination might be benign, but that same connection combined with a new process execution and a sudden access to sensitive data might be a stronger signal. Correlation is the logic that brings events together based on shared attributes like time windows, user accounts, device identifiers, addresses, or session identifiers. In SIEM, correlation can be simple, like counting events, or more complex, like chaining conditions across event types. For beginners, it helps to think of correlation as assembling a puzzle, where each piece is an event and the matching edges are the shared attributes. The purpose is to reduce noise and increase confidence by requiring multiple supporting signals before raising an alert. Correlation can also help with investigation by showing related activity around an event you already care about, which saves time and helps you see scope. Alerting is where the SIEM takes correlation and turns it into a prompt for action, but alerts have to be understood carefully. An alert is not proof of an attack. It is a signal that something matched a rule or model that might represent risk. Alerts can be based on known suspicious patterns, like repeated failed logins or unusual privilege changes, or they can be based on anomalies, like an account behaving differently than its baseline. Alerts often include severity, confidence, and context, but those values depend on how well the detection logic was designed and how good the underlying data is. For beginners, the key is to avoid treating alerts as either perfect truth or useless noise. Instead, treat an alert as a hypothesis that needs validation, and your job as an analyst is to gather evidence that supports or disproves it. In real work, many alerts are false positives, meaning they look suspicious but are benign, and managing that reality is a major part of SIEM operations. The goal is to create alerting that is actionable, meaning it leads to clear next steps rather than endless guessing. Analyst reality is a phrase that captures the practical environment in which people use SIEM, and it is important because it shapes how you design and interpret detections. Analysts often face high alert volume, incomplete context, and time pressure, and they must decide what to investigate deeply and what to close quickly. They also work with imperfect data, such as missing logs, inconsistent fields, or noisy systems that generate repetitive events. This means that an analyst's success depends on process and judgment as much as on technical skill. A good analyst learns how to triage, how to gather context efficiently, and how to escalate with clear evidence when an incident is likely. They also learn how to recognize common benign patterns, like scheduled jobs, system maintenance, or legitimate administrative activity, so they do not waste hours on normal operations. Another part of reality is that analysts work in teams, and they need consistent documentation and handoffs so investigations do not restart with each shift. The SIEM is a tool, but the workflow is what makes the tool effective. A helpful way to understand SIEM analysis is to think about the difference between detection content and investigative context. Detection content is the logic that generates alerts, such as rules that look for suspicious patterns or correlations. Investigative context is the additional information an analyst needs to decide what the alert means, like asset criticality, user role, typical behavior baselines, and known plan changes. SIEM can provide some context directly, but many organizations need to enrich SIEM data with information from asset inventories, identity systems, and business classification. Without enrichment, alerts can be technically correct but operationally confusing because an analyst may not know whether a system is critical or whether the user is an administrator doing legitimate work. For beginners, this helps explain why the same alert can be urgent in one place and low priority in another. It also explains why building a good SIEM program includes not only writing detections, but improving the context around them. When context is rich, analysts can make better decisions faster, and when context is poor, analysts spend time chasing basic questions instead of investigating threats. It is also important to understand that normalization and correlation are not one-time tasks. They require continuous adjustment as systems change. New log sources are added, formats change with upgrades, fields appear or disappear, and business operations evolve, which means detections can break or become noisy. Analysts often discover these problems during investigations, when they notice that data is missing or that a field is not reliable. This leads to a feedback loop where analysis drives improvement, because a good SIEM program learns from what analysts see in daily work. A detection that generates too many false positives might need better correlation conditions or better filtering. A detection that misses real activity might need broader data coverage or improved normalization. For beginners, the key lesson is that SIEM is not a set-and-forget system. It is a living capability that requires tuning. That tuning is not just technical, it is aligned with threats, business priorities, and available response capacity. The best SIEM programs treat tuning as a normal part of operations rather than as a sign that something is broken. When you bring these ideas together, you can describe SIEM analysis basics as the combination of collecting data, making it comparable, connecting it into patterns, and turning patterns into actionable signals for humans. Normalization creates a common language. Correlation creates meaningful relationships, and alerts create prompts for investigation and response. Analyst reality reminds you that the goal is not perfect detection, but effective detection that teams can handle, trust, and act on. For beginners, the most important takeaway is that SIEM is about turning logs into decisions, and decisions depend on data quality, context, and workflow. If logs are inconsistent, normalization fails and analysis becomes slow. If correlation is weak, alerts become noisy or blind. If context is missing, analysts cannot prioritize correctly. And if workflow is unclear, even good alerts can be mishandled. Understanding these basics prepares you to connect earlier topics like logging and incident handling to the practical world of monitoring and investigation, where the job is to see the story in the data and act before the story becomes a crisis.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.